Hey guys, today we're going to work with pyramids. Okay, so pyramids are going to be a lot like the cones that we did yesterday. The only difference is you won't have a circle as a base. Okay, we're only going to have 3 different bases when it comes to pyramids though, because they are a little bit tricky because there's a couple different triangles you have to work with inside of them. So to simplify things, we're only going to be working with squares, equilateral triangles, and hexagons. Okay, so it'll just be those 3 bases that we're going to stay focused on. And we'll do one example of each here so you have those when you're working on your assignment. Okay, first thing you'll notice is that just like inside of your cone you have this right triangle, you also have it inside of your pyramid as well. Okay, and you have to find those 3 pieces. They are going to be used here for us. Okay, so you'll notice you have height. You have slant height still, but you'll notice you have A here. That A stands for the apothem. Okay, so we're going back to working with the apothem that we worked with last chapter. Okay, so instead of radius, that's going to be apothem, and it is going to be important we figure all those pieces out. Okay, the other important thing when you're working with these is you're also going to have to work with the triangles that we worked with when we were working with the apothem back in chapter 11. Okay, so we're also going to have to work with this one that is down here on the base as well. Okay, and if you remember, we can find the measurements for that one. Okay, so this triangle on the base will either be a 45-45 or a 30-60, so we'll always use patterns on it. Okay, this one that goes upright, okay, we will always use the Pythagorean theorem on. Okay, so a lot of our right triangle stuff, again, is coming back that we will have to use and we need to use here, all right? But before we dive into that, okay, let's just go ahead and write down our formulas. They're very similar to the formulas you had for cones. Okay, so for LA, it's going to be 1/2, but instead of circumference, we're going to do perimeter times slant height. And that will always be the perimeter of your base. So that'll either be the square, the equilateral triangle, or the hexagon. Okay, for surface area, it's going to be LA plus B, just like it was for cone. And volume is still going to be 1/3 area base times height, just like it was for cone. Okay, so these 2 are the same as cones. This one's got the change of circumference to perimeter. Otherwise, they're pretty much the same. All right, so let's go ahead and dive into these so you can kind of see how these triangles are going to work for us. Okay, we have given you pictures of these ones because these ones are a little tougher for us to draw. Okay, so I think it's always a little bit easier if we have pictures of them. Okay, so the first one, it tells you have a square pyramid with sides that are 10 meters. So a whole side is 10. And it tells you have a slant height of 13. So again, that would be like this one here. Okay, so first thing you have to do, always do on these, is you have to find your apothem. Okay, these kind of have a set order of the way you're going to do things. Okay, so to find my apothem, I first have to figure out, okay, what my angle measurements are here. So again, if you take 360 divided by 4, because it's a square, you get 90. And then you cut that in half, which tells me it's going to be a 45-45-90. Now, squares are the easiest to work with because if it's a 45-45-90, half a side is 5 and the apothem is 5. That only works for squares. Okay, but again, whole side's 10, that means that has to be 5, and then that would be 5 because it's a 45-45. Okay, so that tells me this is 5. Okay, so now I can use the Pythagorean theorem to find my actual height. Okay, you might recognize we used this one the other day for cones as well. Okay, it would be 5 squared plus your h squared equals 13 squared, or if you recognize the Pythagorean triple, it is 12. Okay, and once you have that triangle solved, you have everything you need. The only added part for today is you've got to work with these ones from chapter 11. Okay, good news is they're not new. It's just how well did you learn them the first time? Hopefully pretty well. Okay, so we'd have 1/2 our perimeter. One side is 10. 10 times 4 would give me 40. Times my slant height, which we found to be 13. Okay, multiply those and you'll get to 60. Okay, so for surface area then, I'll take the 260 plus area of base. Squares are pretty easy. It's just base times height. Okay, so if I've got a 10 times 10, that would give me 100. So I'd end up with 360. And then last but not least, area of base would be the 100 I have above here. Height would be the 12 that we found using our Pythagorean theorem. Okay, multiply those together and you'll get 400. Okay, so again, this part's not hard once you get the triangles figured out. Okay, that's the big part. And again, this stuff is very important for the ACT. Okay, so make sure, a lot of you are taking that next year or in 2 years. Okay, going to be very important, okay, that we know all of this right triangle volume area stuff. They tend to like this stuff as you go through it. Okay, next one we're going to do is going to be an equilateral triangle. Okay, so that's the big triangle. Again, if it helps you to draw it off to the side, go ahead and do that. Some kids find that helpful because it gets a little messy in here. And then that's the other triangle that we'll have to use. All right, so for this one, it tells you that you have side that's 6 feet. And it tells me my slant height is 8 feet. Okay. So again, first thing we need to do is find the apothem. Okay, so this time we're dealing with a triangle. So 360 divided by 3 would be 120. Cut that in half, you would get 60 for the top angle, which means this one would have to be 30. Okay, a full side is 6, which tells me half a side would be 3. That makes 3 my long side. Okay, to go from long to my short, which is what I need for my apothem, I divide by the square root of 3. Okay, when you simplify that, you'll just end up getting an apothem of square root of 3. Okay. So then last but not least, we need to find our height. Okay, to find our height, we have to use Pythagorean theorem. This one's not a Pythagorean triple, so you're going to want to write it out. So I could do square root of 3 squared plus my height squared equals 8 squared. Remember, these just cancel each other out, so you just get 3. Divide your 3 and get 61. Take the square root. There's nothing that goes into it, so it would just be square root of 61. So once you have, again, those pieces, then the rest of it is fairly easy. Okay, I shouldn't say easy, but easier than that stuff we did before. So it'd be 1/2 perimeter times slant height. So one side was 6. 6 times 3 would be 18. Slant height was given to us as 8. Multiply those and you'll get 72. Area of base. Now, triangles, you have 2 options. You can use 1/2 base times height or 1/2 PA. But since you already know the apothem and you already know the perimeter, you want to use that one. You do not want to use 1/2 base times height here. Okay, so I'm going to do 1/2 perimeter, which is still 18, and apothem, which is square root of 3. Okay, you already have all the information. Don't make it harder on yourself. You don't have the height of the base. You would have to find that, which then, again, just makes everything much more difficult. I cannot add these together, okay, because of that square root of 3, so I will just have to leave those 2 separate. Okay, and then last but not least is the volume. So area of base would still be this guy. And then times our height, which we found to be square root of 61. Now this one, just be careful when you're kind of putting it all together with yourself. Okay, so you could multiply the 1/3, the 1/2, and the 18 together. If you do that, you'll get 3. And then you can multiply your square roots together, okay, and you'll get square root of 183. Okay, if you could break down the 183, you would, but nothing else goes into it, so we'll just leave it like that. All right, so that would be a triangular pyramid because of the triangle on the bottom. Okay, so we'll look at one more here with a hexagon on the bottom. Again, they're kind of all done the exact same way. Okay, you have kind of the same order when you're solving them. Alright, so for this one they tell us that you have sides that are 4 inches and a height that is 10. Notice this time they gave us the regular height, not the slant height, not a big deal. Okay, we're still going to solve for the apothem first. Okay, so again, first thing we have to do is figure out our angle measurements here. Okay, so 360 divided by 6 is 60. Cut that in half and I'll get the 30 up here and the 60 down here. Okay, so this would be half a side, which is 2. That's my short side. My apothem would be my long side, so that'd be 2 square root of 3. Okay, so now we want to use Pythagorean theorem to find our slant height. Okay, so it'd be 10 squared plus 2 square root of 3 squared equals our slant height squared. Must be in parentheses. Okay, got to make sure you square the whole thing, not just part of it on that one. Okay, once you get that, then you want to simplify it. Once you simplify your square root, you should get 4 square root of 7. Okay, once you have that, you then again have everything you need. Okay, so LA would be our 1/2 PL. So if one side's 4, 4 times 6 would be 24, times our slant height, which is 4 square root of 7. Multiply those and you will get 48 square root of 7. For surface area, it's LA plus B. Again, hexagon, we're going to use 1/2 PA. Which again, you have all the information for, which is really nice. There's your perimeter, there's your apothem, just plug them in. Square roots are different. We cannot add them when square roots are different, so we will have to leave them separate. We can multiply, we just can't add. And for volume, again, take that area of the base and take it times your height, which is 10. Again, you can multiply all the regular numbers, just don't throw the square root in there, and you'll end up with 80 square root of 3. Okay. So I know these ones can be a little tricky. You may have to watch this video more than once. It all comes down to how comfortable you are with this right triangle stuff. Okay, this again on the bottom will always be a 30-60-90 or a 45-45-90. Okay, the one that's upright will always be Pythagorean theorem. Okay, so just keep that in mind. You always have to find the apothem first, and then you can do Pythagorean theorem, and once you have this one, then it translates to this stuff really nicely. Okay, but it can be a little tricky, which is why we're going to practice it a little bit more tomorrow as well. All right, have a great rest of your day.